We need to find the value of this particular expression. We have a raised to the power of some logarithmic expression. So let's begin with the exponent part, that is the power part. So here we have log of 1 with the base of a plus 2 times log of 2 with the base of a plus 3 times log of 3 with the base of a, and this continues all the way up to n times log of n with the base of a. So here we see there are like n numbers. So here n represents some n numbers of logarithmic terms that are added to each other, and all of them have base of a. Since all of them have a base of a, that means we must be able to add them using a property that's log of a plus log of b, which is equals to log of a times b. But in order to do that, the coefficient of log must be 1. So for the first one, there's no issue. But for the second term and the consequent terms, each of them has a coefficient. So we need to get rid of that coefficient. Now to do that, let's look at the second term. We have 2 times log of 2 with the base of a. So we will be using a property. Let's say a is multiplied to log of b. So this is the same as log of b raised to the power of a. Now that means we can use this to rewrite our second term and all the consequent terms as the first terms. We don't have any issue. Log of 1 with the base of a plus log of 2 squared with the base of a plus 3 log 3 will become log of 3 cubed with the base of a plus the other terms, and the final term will be log of n raised to the power of n with the base of a. Now we can successfully apply our property log of a plus log of b equals to log of a times b. That means we have log of base a. Now we'll multiply 1 with 2 squared with 3 cubed. Next will be 4 raised to the power of 4. So you can see the trend, and this goes all the way up to n raised to the power of n. Right. So this will be our value of the power part or the exponent part. Now we have a raised to the power of log of 1 to the base of a plus 2 log 2 to the base of a. So this goes all the way up to n times log of n to the base of a. So this is equivalent to saying a raised to the power of log with the base of a of 1 times 2 squared times 3 cubed times 4 raised to the power of 4 all the way up to n raised to the power of n. Now luckily there is a property of logarithm that says that if we have a raised to the power of log of b with the base of a, that means the base of the exponent is a and the base of the logarithm is also a, and when they are the same, then this expression will be equals to b. So in our case, we have the base of the exponent as a and the base of the logarithm is also a, so they are equal. That means this will become equals to 1 multiplied to 2 squared to 3 cubed to 4 raised to the power of 4 all the way up to n raised to the power of n. So this is our final answer. So the value of a given expression, so that will be 1 raised to the power of 1 times 2 raised to the power of 2 times 3 raised to the power of 3 times 4 raised to the power of 4, and this goes all the way up to n raised to the power of n.